Hi, I'm Shivani Trivedi from ABES Engineering College, Ghaziabad. In this lecture, we are going to take PAL, Programmable Array Logic. We have already discussed about PLA in my previous lecture, and it is very much possible you have been directed here after seeing that PLA lecture. So, here it is. Before going to PAL, I would like to mention some points. First thing is that it is very much favorable that you had already studied about PLA. It will help you in this lecture. Another point is that if you look into your book, that is your Morris Manu or any other book, you will find that they have showing some tables. And according to me, I don't feel like any table to be required to understand this PLA. So in this lecture, I would try to make this lecture as simple and small as possible. So let's move to it. So these are the outline that I am going to cover. Introduction to PAL, one example of PLA, so that you can easily understand how to implement the circuit of PAL. So let's move to it without wasting any time. So what is PL? PL is basically a programmable array logic, and it is the most commonly used type of PLDs. It is programmable logic device. Why it is most commonly used? Because in this we are using the fixed OR gate. Fixed because of this for fixed OR gate. We don't have to worry about programming the OR gate like in PLA. Here in this PAL, the OR gate is fixed. One gate is programmable and another one is fixed. In the PLA, you have seen that we are using both the gates in the programmable form, but in PAL, we have fixed OR gate and programmable AND gate. Advantage of PL is this only because of fixed OR gate, it is simple. Simplicity is there, but there is one disadvantage that it is not very much flexible like that of PLA. So actually here you can see one circuit. I'm showing this. Actually, this is the last step in any problem. In any problem of circuit implementation, this designing is the last step. But I try to make you feel how PAL is. In this, you are seeing you see that there are fixed OR gate. This dot symbolizes that this OR gate is fixed, and this cross, this symbolizes that we have programmable AND gate. So you can easily understand the difference between, you can easily visualize the difference between the PLA and PAL. So let us move further to by taking one example. I'm taking one example of PAL. So step one to see the minterms. I'm taking the minterms A, B, C of three variables x, y, z. X for x function, minterms are 2, 3, 5, 7. For y, minterms are 0, 1, 5. And for z, minterms are 0, 2, 3, 5. Now, step 2, from these minterms, I am trying to derive the minimal SOP. How we'll get the minimal SOP? I have already discussed in the PLA lecture. For finding the minimal SOP, we have made the K maps. So with the help of K map, we minimize it. Next step is K map. For X, I am making the K map. K map of three variables total, 8 cells. A bar, A, B bar, C bar, B bar, C, BC, and BC bar. For X, K map is 2, 3, 5, 7. 2, 3, 5, 7. ठीक है. I'm getting two pair. So for X, equation is A bar B plus A C. AC and A bar B. Yes, I'm correct. Next, for Y, again, K map of 8 cells because there are 3 variables. A bar A, B bar C bar, B bar C, BC and BC bar. 0, 1, 5. 0, 1, 5. I'm getting two pairs. For Y, equation is A bar B bar plus B bar C. Getting two midterms in Y. For Y, similarly for Z, again K map of 8 cells. A bar A, B bar C bar, B bar C, BC and BC bar. Yes. 0, 2, 3, 5. 0, 2, 3, 5. Yes. One pair from there, another pair, and for this only single pairing. So for Z, equation is A B bar C plus A bar B plus A bar C bar. Let me check. For this, A bar B C bar, A bar, and for this, yes, A bar A B bar C. For this single pair, A B bar C. Yes. For this pair, I am getting A bar B, and for this one, A bar C bar. Yes. Now our last step third, is to design the circuit according to our equation. We write the equation. I'm writing the equation. X A bar B plus AC, Y A bar B bar plus B bar C, Z A B bar C plus A bar B plus A bar C bar. I'm getting A bar B. Okay. So tell me how many number of input buffer we have required? We have to require 3 input buffer. Number of input buffer equal to, why we have to require 3 buffer? Because there are 3 variables. For A, for B, for C, three input buffer, A bar, B bar, C bar. Now, here comes the difference. You can see there are total 2 minterms in X and Y, but in Z, there are 3 minterms. So in this PAL, there's a difference between PL and PL at this point only. We have to require 3 because 3 is the highest number. In between 2 and 3, 2 and 3, 3 is the highest number. So we have to require 3 AND gate for each function. So total we have to require 9 AND gate. 3 for this, 3 for this, 3 for this. Why I'm getting 3? Because 3 is the highest number of minterms in all the function. X, Y and Z तीनों के बीच में 3 highest है. इसमें 2 है, इसमें 2 है, इसमें 3 है. So यहाँ पर हमें highest minterm लेनी है, वो है हमारी 3. 3 एंड गेट, 3 प्रोग्रामेबल एंड गेट आपको तीनों फंक्शंस के लिए लेने. टोटल यहाँ पे 9, टोटल यहाँ पे हमें 9 एंड गेट चाहिए. 1 2 3 4 8 and 9. How many number of OR gate? 3 OR gate. It is similar to PLA. We have to require 3 OR gate for each function x, y, and z. X, y, and z. Yes. Yes. First midterm, A bar B. A bar B. Second midterm, AC. A and C. Now, as I have told you that I am taking 3 programmable AND gate for function X, but there are only 2 midterms. So this gate is not used for X. So I can tell for this I am not connecting any line. So there I am using fuse intact. Fuse intact. What does it mean? That I'm not using this AND gate. So as you can see here, I'm using cross. This shows that I'm connecting these lines to this AND gate. But for this AND gate, I'm not using this AND gate. So I have disconnected. So this is known as fuse intact. Again, A bar, B bar, and B bar, C for this. Again, for Y function, again, I am not using this programmable AND gate because there are only 2 midterms. So for this AND gate, fuse intact is there. For Z, midterms are A, B bar, C. For this, A bar, B. For this, A bar and C bar. Yes. Next point. Next. For X, how many midterms are there? A bar, B, and AC. So I am here using dot, which shows that your OR gate is fixed. You don't need to worry about the OR gate because their OR gate is fixed. You have to program only the AND gates, A bar, B, and AC. Next, for Y, A bar, B bar, B bar, C, and this also. For Z, so this is the whole circuit for the programmable array logic. You can easily see the difference that in this PAL, we are using the AND gate as programmable, but I am not using the OR gate as programmable like in PLA. Here, OR gate is fixed. So this completes the PAL logic. In the further lecture, I'm going to explain you about implementation of full adder using PAL. These are the references that I'm using for this lecture, and thank you.